What is mean algorithm? Algorithm is a step-by-step procedure. It defines a set of instructions to be executed in a certain order to get at desired output. So there is no set of rules. There is a standards in writing the algorithm. But it gives the clear-cut idea how the program is going to execute and to get the desired output. Other can be implemented in more than one programming language, only the program code differs. So there is no, it's not programming code independent. It is independent of any programming code. And some important categories are searching algorithms and sorting algorithm, inserting, updating, deleting. So next, the characteristics of an algorithm. Now all the procedures can be called as an algorithm. Must have some characteristics. So what are the characteristics? Steps followed should be very clear. The input must be well defined. The output should match the desired output. Finiteness should terminate after the finite number of steps, that is, looping will not be allowed. And feasibility should be executable with available resources. Independent should be independent of any programming code. How to write an algorithm? There is well-defined standard for writing the algorithm. It is problem and resource dependent. So how we are going to write the algorithms? First we have to analyze the complexity of the algorithm. So algorithm analysis first. A priori algorithm, it's a theoretical based analysis. It doesn't think about the execution of the program. It just says the machine speed, machine specification, and have no effect on implementing the program in the machine, targeting machine. So the output must be theoretical. Usually it's not correct. Why? Because it's theoretical. After implementing, the output may differs. The speed and execution differs because of the typing speed. Whatever it is, the coding speed, code error, number of line extra, you're giving extra number of lines. These are things that programmer always execute. So post-truth analysis means it's empirical, that is running the program into automation and find the efficiency by running time space meter. So when implementing the code in the machine, and after implementing, we can able to find the efficiency of the machine by calculating the running time space needed for executing a program like this. And complexity analysis, complexity in the sense we are thinking always about time factor and space factor. Time factor in the sense measured by counting the number of key operations. Counting the number of key operations means we're counting the number of code executed, number of codes executing, and by counting the code, each code has a certain number of times to execute. So by that we can able to count the time factor. And space factor, to the space required to execute the program in this fixed path and variable path. Fixed path in the sense the space will be already fixed. In the fixed path itself we have to execute the program. If there is need of extra space, it cannot be allocated. So variable means it's dynamic. During execution, if there is need of space, or if there is a less amount of space already, if there is no need of extra space, we don't have to execute. If we need extra space, we can able to get it while executing the program. This is what is the variable part. A recursion. Some computer programming language allows a model to function to call itself. A function A call itself. A function B call that it call A. Then the function A is called recursive function. Why I'm saying A and A is a recursive function means A call by itself, so it's a recursive, and B call A, it's also recursive. A call B call A, and then A itself call B itself. B A B A B A B. It keeps on going, and it's also recursive. Then the function A is called recursive function. An example function call itself in function of int variable, int value. If value less than in, return. If value minus 1, function value minus 1, print the value of the function. Properties of the recursion. Recursive function can be infinite, like a loop. To avoid basic criteria, giving a condition so that given condition is met, the function stop calling itself. After the condition met, stop calling itself. For example, if the value of a less than or equal to 5, the loop will not go beyond that condition. That is, after 5, the loop will not execute beyond 5. Then progressive approach, the recursive call should progress in such a way that each time a recursive call is made, it comes closer to the base criteria. What does it mean by the program is going to execute 5 times. After executing 5 times, it moves 1 step forward. After executing 2, it moves 2 steps forward to the output. And after 3, it moves 3 steps. After executing 4, it moves 4 steps. There's only 1 step remaining. After 5, there's no need of execute again. And implementation. Many programming languages implement recursion by means of stack. Whenever a function, that is caller, calls another function callee, the caller function transfers execution control to the callee. That is, for example, I'm calling a student and ask to do such a things, and I'm giving the control to that student. He's going to execute my orders. That is what going to happen here. The caller gives the control to the callee. The callee executes the program and gives the output to the caller. This is what happens here. An analysis of programming recursion, that's time complexity and space complexity.